The multiplication rule for counting generalizes the calculations we were completing in the previous example and gives us a process that we can apply to, again, situations where counting manually might be very cumbersome or nearly impossible. So the multiplication rule for counting tells us that if there are n ways to accomplish one task and m ways to accomplish a second task, then there are n times n ways to accomplish both tasks. Again, this is a generalization of what we just looked at in the previous example. We were taking each of the 4 suits times, say, the number of numbered cards, the number of face cards, to generate those different results. We can apply this to other scenarios as well. In example 1, we have a true-false quiz with 9 questions. We want to know how many different ways there are to respond to this quiz. We know there are 9 questions in total. Since it's a true-false quiz, we can infer that there are 2 possible answers for each question. So we can take 9, the number of questions, times 2, the number of responses for each question, to get that there are 18 total responses, total different ways of responding to this quiz. In example 2, we have a company that builds custom beds offering 4 different sizes, so that's one of our possibilities, with 3 different heights, but now we're going to continue to include more than just 2 options like we've looked at so far. There are also going to be 3 types of wood and 5 styles of headboard. So now we're taking this idea of n times n and just adding multiple different tasks that we're combining together. So to get the total number of configurations, if a customer chooses one of each of these, we would take the number of different sizes for beds, so 4, times 3 different heights, times 3 different types of wood, times 5 different styles of headboard, gives us 180 different possible combinations for beds that a customer could order. We can continue to expand this idea for more tasks or more options to choose from. In example 3, a toy company allows you to create customized figures of yourself. If you can select from 3 body types, so we have 3 options for our first choice, times 4 skin tones, times 35 hairstyles, times 8 hair colors, times 6 styles of facial hair, including no facial hair, times 5 styles of glasses, including an option for no glasses, times 13 different shirts, times 7 different pairs of pants, times 12 different accessories, including the option for no accessories, and times 14 different options for a pet, including no pets as an option. Multiplying all of those, the different possibilities for those different choices together, gives us 1,541,030,400 different choices that a customer could build in this process. For a case like example 3, we're starting to get into that realm of not just tedious to count all these options, but possibly nearly impossible to go through and manually map out all of those different combinations and count them one by one. In example 4, we have a pizza restaurant that sells pizza with one size, one type of crust, but you do get to choose between 6 different crust toppers, 7 different types of veggies, and 6 different types of meat toppings. If a basic pizza lets you pick 1 crust topper, 1 veggie topping, and 1 meat topping, how many different pizza combinations are possible? For the crust topper, we have 6 different options. So we'll take the 6 different options times the 7 different options that we have for our veggie selection, times the 6 different options we have for our meat selection, and multiply those together to get 252 different combinations of pizza. A super pizza lets you pick 2 crust toppers, 2 veggie toppings and 1 meat topping. Same question, how many different pizzas are possible? And we have a note that we can choose the same item twice. So if you want double the amount of green peppers, you can choose green peppers twice as your veggie option. That means that we have 6 different choices for crust toppers, 6 different options for the second type of crust topper, 7 different options for veggies, 7 different options for our second choice of veggies, and then 6 different options for our choice of meat, giving us 10,584 possible types of pizza. In the last part here, an ultimate pizza lets you pick 2 crust toppers. So again, we have 6 options for that first choice and the same 6 options for that second choice. 3 veggie toppings, so times 7, times 7, times 7, since we can choose that same veggie option if we just want to load it up with one kind of vegetable. And then we get 2 choices for meat toppings, so we have 6 options with that first choice and 6 options again with that second choice. Multiplying all those values together gives us 444,528 different types of pizzas that are possible.